The objective of this experiment was to determine the coefficient of static friction of different surfaces. The apparatus that we have used in this experiment were, first, wooden block, which is rubber covered at one side, string, 10N spring scale, tabletop, and 50-gram masses.
Force is a vector quantity, which means it has both magnitude and direction. Force exists when the object accelerates or undergoes a change in its velocity. A body at rest has the sum of all forces equal to 0. Gravity is an attractive force that exists between two masses. The magnitude of the force depends on the magnitude of the masses. The gravitational force that acts on an object on Earth is approximated as Fg equals to mg, where m is the mass of the object and g is the gravitational acceleration. The magnitude of the gravitational force exerted on an object is referred to as its weight. Next, we have the normal force. The normal force is a contact force that acts in the normal direction or perpendicular to the contact surface between two objects. An example of a normal force acting on an object is with this free body diagram where a mass is lying on a horizontal surface. So when a mass is on a horizontal surface, the N, or normal force, is equal to mg, which is the gravitational force. Next up, we have friction, which is the force that resists the relative motion of one surface in contact with another. So this means that if for example, the object is moving to the right, then the frictional force would be to the left, which is the opposite direction of the relative motion of the object. There are two types of friction, which are static and kinetic. Static friction is the friction that acts on an object that is at rest. Static friction is the force that must be overcome in order to move a static object. The maximum value of static frictional force is given by Fs max equals to micro s n, where micro s is the coefficient of static friction and n is the normal force. The coefficient of static friction is a dimensionless constant that depends on the object and the surface it is laying upon. So moving on, we have kinetic friction, which is the friction that acts on a moving object, and the kinetic frictional force is given by Fk equals to micro k n, where micro k is the coefficient of kinetic friction and n is the normal force. In this experiment, the frictional force between a wooden block and the rubber surface on a horizontal and inclined plane will be measured, and from the plotted data, the coefficients of static friction will be obtained.
Procedure 1. Measure the mass of wooden block, record as m. 2. Set up the apparatus. 3. Make sure the tabletop is stable and horizontal to the ground. 4. Attach the spring scale and the wooden block with the string. Place them horizontally on the tabletop. Make sure the rubber side of the block is faced downward. 5. Place a 50-gram mass on the wooden block. 6. Pull the spring slowly. Once the block starts to move, record the spring scale's reading. 7. Repeat step 4 until 5 for 3 trials. 8. Add another 50-gram mass on the wooden block and repeat step 5 to 6. Repeat the steps until total of mass equal to 500-gram mass is on the wooden block. Lastly, repeat step 1 until 8. This time, make sure the rubber side of the block facing upward. Tabulate the data in table.
Question 1. How can anti-lock brake stop a car in a shorter distance than regular brakes? Anti-lock braking system cars have sensors. As soon as the sensor senses the wheels are about to get locked, the motor releases the brake pressure. Even when continuing to apply brakes, the sensor system applies and releases the brakes several times after sensing wheel lock. As a result, the steering wheel remains free and getting fresh brake pressure many times per second. It increases the brake force and the vehicle stops in a short span of time. Next, the material has the highest coefficient of static friction is wooden block with rubber covered. The hypothesis is agreed, which is a higher coefficient of static friction applied by raw surface of object-to-object contact and the weak puts force on the block. We think to determine the coefficient of static friction depends on the material used. Last answer is, once the mass begins to slide, it undergoes stop and go motion. The mass experiences a frictional force exerted by the surface, which opposes its motion. It experiences an internal force exerted by the body itself, which opposes its motion. Sliding friction is applied in this motion, which is the force acting against two objects sliding against each other. Sliding friction is less than static friction.